we did A1 together, and we started A2. Your A2 should look like this, table right over here, where plan 1 is starting at that -3, that y-intercept. Plan 2 is starting at 6, that y-intercept, and then plan 2 is 2 all the way down. You'll notice there's some patterns that are going on here. If we look back at what it's asking me to do, make a table, it should look like mine. Your graph should look like these graphs here. Now your scale will hopefully go up to 22 and all the way down to -28. So yours will be a little bit different than mine. But for plan 1, that's the black line here, that should go through -3, and it should rise up 5, 1, 2, 3, 4, 5, and it should go over 1. For plan number 2, it should start at that 6 right there. It should go down 1 over 1, down 1 over 1. We're seeing this pattern that's going on here. A4 is asking, do the y values increase, decrease, or stay the same as the x values increase? If I look at my table, say as my x values are increased, we're going this direction. My y values are also increasing in plan 1. As my x values are increasing, what's happening to my y values in plan 2? Well, they're decreasing. And in plan 3, my y values are staying the exact same thing. I see that on my graph as well. For plan 1, this black line, as x is increasing, my black line is increasing. For plan 2, the red line, as x is increasing, it is decreasing in y values, and the green line is staying the exact same way. Now we can see this in the equation as well by us looking at that unit rate. Because this constant rate right here is a positive, then plan 1 is going to be going in a positive direction. The y values are increasing as the x values are increasing. Because this guy over here is a negative, then we're going to see that my y values are decreasing as x is increasing. When we look at B, it's asking which graph contains the point 2, 4. So we're going to head over here. I know that the 2 is the x. I'm going to go over to 2. I'm going to rise up to 4, the y, and that means that the red is plan number 2. How do the coordinates relate to the equation of the line? Well, if I think about my equation, I know that I have y equals -x plus 6. I'm going to put this in for my x value, so I have y equals -2 plus 6. And if this over here actually equals what the y value should be of 4, then we're good to go. -2 plus 6 does equal 4. Therefore, I know that this coordinate goes with this equation. Write a question you can answer by locating this point. I'm going to let you guys do that one because there's going to be a lot of variation there. For C, which relationship has a graph you can use to find the value of x that makes 8 equals 5x minus 3 a true statement? Well, I should probably see that this right here, the 5x minus 3, that relates to plan 1. And they have now given me a y value of 8. So I'm going to need to solve for the x value. That's what number 2 is asking me. How does finding the value of x in this equation help me find the coordinates for a point on the graph of the relationship? So we're going to go ahead and solve for x. I'm going to say, well, I know that 8 is equal to 5x minus 3. There's a few ways we could solve this. One, I could look at my table and I could say, well, when the y equals 8, what does my x equal? That was a little bit trickier there. I can think about when y equals 8. Oh, my line is off, excuse me. When y equals 8 over here, wrong plan, excuse me. When y equals 8 over here, it's going to be somewhere in this range. All right, so between 2 and 3, which is roughly what we're seeing here. So in order to solve this, we're going to add 3 to both sides. Thinking about that party. I want all those numbers to be on the same side. I know I have an 11 over here. And I'm left with 5 x's over here. This is a multiplication. To undo this multiplication, I'm going to divide both sides by the coefficient. So divide both sides by 5. And that tells me that x is equal to, you could say 2 1/5, or you could say 2.2. All of those would be the exact same. So how does finding this value help me find the coordinates for a point? Well, when I look at my graph, I think, hey, the y I'm given is the 8. Over here, I know it's between the 2 and the 3 somewhere, and finding that x helps me solidify what that actually is. And looking at D, find 3 points all lie on the graph on the same plane. 2 of the points have a missing coordinate. Find the missing coordinate. So I'm going to look first for the one it gives me, -7, 13. Over here, -7, and we're going to crawl on up, and my line is a little bit off, but it should be that guy right there. So I'm saying that that is for plan 2. So I'm going to say, well, 1.2, well, that's kind of tricky. So I can put that actually into my equation. I have y equals -1.2 plus 6. When I go ahead and solve this, a -1.2 plus 6 gives me 4.8. That y equals 4.8 for this one. Well, let's double check to make sure that sounds about right. X is about 1.2, which means that this line is at about 4.8. That looks pretty gosh darn good. The other one is when my y value equals -4. Again, it's all on the same line. So when y equals -4, when y equals -4, way down here, okay, what is my x value? Well, my line stops, but I'm going to estimate that it's going to be somewhere between the 10 and the 11. Let's go ahead and figure out what it looks like. I'm going to put in -4 in for the y. All right, we're going to subtract 6 from both sides. I'm going to subtract 6 over here. This over here, -4 minus 6 gives me a -10, is equal to a -x, which means that x is equal to 10. So does that fit with my graph? Well, y equals -4 over here, x equals -10. Again, my line is a little bit off. I apologize for that. But that would make sense over here. As well as I could look up here and say, well, when x equals -4, what does y equal? Hey, what do you know? It equals 10. And I'm going to move on to the next one. Describe how a point in the graph is related to a table and an equation that represents the same relationship. Well, if I'm looking over here, I mean, it's first off, between a table and a graph is, we're looking for, this gives me the coordinate points. So if I look at -1, -8 for plan 1, that is the coordinate point. I should see that over here on my graph. So x equals -1, y should equal -8. Perfect, and that would work for anything, any of these 3 plans. Now relating it to an equation is a little bit trickier. And what we're going to see is that it all starts with that starting value, that y-intercept. And then each of these, plan number 1 is going at a constant rate of +5. Plan number 2 is going at a constant rate of -1. And so we should be able to see that relationship between this pattern that's going on here is the same pattern. We're going from here, +5 over 1, +5 over 1, +5 over 1, and the pattern here of -1, -1, -1, -1, -1. We're seeing that same pattern within the equations. How can I use a table, graph, an equation that represents the relationship to find the value of y when x equals 7? What I'm going to do is I'm going to take this 7, because it stands for x, I'm going to substitute right there and solve for y. 5 times 7 is 35, minus 3 is 32. And then find the value of x when y equals 23. I'm going to put 23 into the original equation. So now I've got 23 equals 5x minus 3. I'm going to add 3 to both sides. Which leaves me with 26 equals 5x. I want to find out just what x is, so I'm going to divide both sides by 5. And then I see that it is 5.2, excuse me, that's 2, or 5 1/5 equals x.